All right, here's my belt tensioning solution here. So I would have much rather had something coming in from the bottom that was more integrated, but this is extremely simple and it works surprisingly well. So I started with these idler blocks, just like thumb tight, push down, and then snugged them up to the C-beam. And that, I think, was not good enough. So I made these tensioner blocks here, which are just the same spacing to fit the C-beam. And then there's a hole in the middle for an M3 brass insert that I put in there. So I just put that flush up against this idler block, tightened it in, loosened up this idler block, and then slowly tightened this screw, which pushed on the center down there and tightened it up. And when I reached a tightness that I thought would be good for the next round of testing, I just snugged up this idler block again. So 2 here and then 2 for the back. And that seems to work great. It's very controllable, and if you want to, you can even remove this tensioner to clean up the look. But where it is right now, it's not in the way of anything, so I'm going to leave it. Another thing that would be good if I get there would be to just shorten up these belts and make them the minimum length possible. Right now they're quite a bit longer than they need to be. And with this method, I was able to get them all pretty consistently to the same tension. So I was just kind of strumming on this and trying to match the pitch. Not exact, but reasonably close. If it turns out to be not good enough, then I may use like a piano or guitar tuner app on the phone to try to get them even closer. And if I can actually measure the pitch and put a number or letter to it, then it would be more repeatable if I have to take this whole thing apart again. And while I was at it, I went ahead and added a second collet clip. So I just trimmed the little tab off of it so I could stack them one on top of the other. And I managed to push that PTFE tube all the way down and then pry up on the collet a little bit. And I was able to sneak 2 collet clips in there instead of just the one I had before. So I'm hoping that will be good enough to take the slop out of that. And on the Bondtech side up here, there doesn't seem to be much slop there. It's a different type of collet connector, but with the one clip I have in there, I think it's good enough for now. But more testing will show for sure. So with tighter belts and an extra collet clip on the Bowden tube, it's better. Still not perfect, but the increased belt tension definitely is making this gyroid infill more sinusoidal looking. And on the first few layers with the 100% rectilinear infill, the ends of that infill did look straighter with less ringing than there was before. Yeah, unfortunate side effect of that, of all these things being tightened up, is it looks like now pressure advance might be more important, because I noticed some plastic seemed to be filling up at the ends of that 100% infill. So we'll see what the top looks like when we get there. And I should also note that in addition to tightening the belts and stuff, I also reduced the jerk setting. So in RepRap firmware, that is M566. So I think I had it a bit aggressive before, so I reduced it to 2,000 millimeters per minute as it's labeled maximum instantaneous speed changes. So that might also be having an effect here. So this is a test print after tightening up all the belts and putting an extra collet clip on the Bowden tube and reducing the instantaneous speed changes in the firmware, otherwise known as jerk. So overall, much better. First layer was a bit close, so it kind of elephant's foot smushed out on the bottom a little bit. Other than that, a similar story to before in terms of dimensions. Overall dimensions are pretty good. However, there's still a very strange artifact on here. So this time I used this clip instead of the wedge, and things were running smoother. So the build plate was not moving around this time. So it was oriented this way on the build plate, with this corner pointing at this axis. So you can see overall it's a lot cleaner than the previous one, but there's this weird bump here, and it's not just a single layer or two. It's like it went out of alignment and then it came back. Yeah, like kind of smoothly bulged out and then came back a few layers later. It's not some type of instantaneous skip or something. And you can see it's on this face and on this face. And over here, yeah, you should be able to see it in here. It's like it went in and then back out smoothly over a few layers. And I've never seen this before, so I'm not exactly sure. But yeah, even on the inside here, you can see it's a divot going in. So I wasn't exactly sure what to check. So I went up and checked the set screws on the timing pulleys on the stepper motors, and sure enough, the ones on this axis right here, where it was bulged out, those were pretty loose. So I'm thinking the timing pulley might have been slipping on the shaft a bit. So I went ahead and removed all the set screws on all the stepper pulleys and put some blue Loctite in there. So we will see if that helps on the next print. After tightening up the timing pulleys on the steppers, got one of the best first layers I've seen out of this yet. Probably a result of more accurate homing and bed probing after adjusting belt tension and the other changes. But yeah, what I'm seeing is on these first couple of low layers where it's less forgiving. There's less flex in the part and less places for excess plastic to go. You can see where the plastic is piling up a bit at the ends of these runs. So yeah, definitely we'll need to jump into pressure advance eventually. Quick note about painter's tape. So I'm wary about prying underneath the part with like a metal spatula or something too hard, because my build plate is aluminum and I'm worried about scratching and gouging it. So I wouldn't have that type of concern if this were glass or something harder than steel. But I'm wary of prying on it too much. And one of my previous attempts where I just whacked it with a hammer and a PL8 wedge, I mean, that worked, but if your part is delicate, that's not a good solution. So some quick Google and YouTube searching, I came across one good article and one good YouTube video where they mentioned all you have to do is pull up the tape around your print and then soak the remaining tape under the print with isopropyl alcohol. And just let that soak for a while, and then eventually it'll just pop right off. And man, that worked like a champ. Super easy. All right, now we're talking. So yeah, this is definitely approaching what I would call a usable print. So that seems to have eliminated that strange bulge that I was seeing. And now this looks, I mean, not perfect. There are still artifacts, either from the stepper drivers or something else in the system. But these are, I mean, these are minor as far as I'm concerned. So this is usable print quality for most of the types of things that I do. So I'm pretty stoked at the moment. Yeah, not perfect, but things are pretty straight and pretty accurate. Yeah, you could see it. You could see up here where the pressure advanced type setting would help with that imperfection there on the top. Not too bad here. In the corner, you can see a little more where plastic was building up from the pressure in the Bowden tube. So yeah, pretty happy with that. Yeah, real quick, just checking. So yeah, there's our Z. Let's check some of these here. Can't complain. So yeah, I'm definitely gonna make some notes and save everything I can so I can at least get back to this print quality if I have to. So dialing in from here would be things like improving quality or being able to print faster, things like that. So yeah, this is great. That's all I got for now. Thanks.